I don't want to go through everything. Introduce myself. I'm essentially just a self-taught geek that I love using Asterisk, and I'm always trying to find more and better uses for saving money. And that's really how this project started. Looks like my slides are being cut off. So back in 2004 in Florida, we had a succession of about 4 hurricanes that came through the state. What ended up happening is the communications were degraded between all the different generating cities or generating sites that we have in Florida for generating power. So they started talking about how they could make a better system for being able to communicate with each other. Because the current system that they had, which was pretty much picking up the phone and calling someone, just wasn't cutting it. So they looked into a system that's known as a hoot and holler circuit. For those of you not familiar, basically it's a proprietary phone-type communication where you can pick up one line and all the others will hear the conversation at the same time. And this would be used to communicate amongst these different generating units to let them know when they need to ramp something up or ramp something down in that type of a scenario. So the estimated cost of the project when they first looked at it was 16 endpoints and about $96,000 in capital. They're looking at about $3,500 a month in telco charges and another $6,700 a month in provider charges. And this was going to be used to also keep the dispatch informed of maintenance routines or any time that they needed to go offline for any specific reason. And the way it was designed that some of the endpoints could actually initiate the call, but everybody could hear the call. And that way everybody was on the same page when something would happen. They also called for 56K lease lines to be placed at each of the locations. And everybody probably realizes that that's not exactly the cheapest way of deploying a solution. And the vendor was touting some security due to the nature of lease lines. But all of the options on that system were a la carte. And they had looked at maybe doing some extra things that's gonna run you more money. So I proposed an Asterisk-based solution based on using PBX and a flash as the base install. With its limited scope, a lot of people might think, well, why'd you use PBX and a flash? It's got a lot of extra overhead to it. But I originally scoped this thing out so that anybody could handle it, and it wouldn't need somebody on the Asterisk CLI to add things, change things, or whatever else. So it made it very easy to scale out to other people that may not be so tech savvy. We also used 15 Astra 53i phones on the system, and it was spec'd out to use the internet connection from the actual entity already, so that kept the cost for the interconnects to pretty much zero. And so the whole project as expected out was about $2,200. So we created the instructions. We programmed a bunch of buttons on the phone to do essentially a page group, and that would just broadcast to all the endpoints and automatically put the endpoints on mute. And took about 2 weeks to roll out. Far cry from the original proposal, which would have been about 6-month rollout, and that was just to get things started. Of course, scope creep always happens. Folks want to do more things. They like the way that it worked. Oh, that was too quick. Can you add this? Can you add that? So we started revamping the project a little bit. And then we want to talk about security. Like how can we secure this thing? How can we make it record all the conversations? Because they found out after the fact that they're required by law to record all these conversations. So that's nice to know up front. And then they wanted to deploy even more endpoints to more people. They wanted to make this installation plug and play as much as possible. Basically just mail out an endpoint, let them plug it in, and then they go. And make the system a little more redundant. What happens if the one box that I've set up fails? Generally speaking, you don't record pages, but of course this is Asterisk and you can do whatever the heck you want. PBX in a Flash uses the free PBX GUI on it, which for those of you who don't know, basically just rewrites config files every time you save it. So I had to do a little bit of customization to actually go through and make it work for us. So I set the recording directory to a directory on our web server. This is actually the same box as the Asterisk. We record everything as a WAV file. Each individual endpoint is paged out, and then the recording starts, and it stops when the originator will hang up the conversation. And nightly, I just go through and convert everything from WAV into MP3 to save space, and those are all available to specific folks that we allow to actually see the recordings. So, talking about securing the communication with the endpoints, when we originally put this thing out, everybody understood that this transmission was going over the internet in the clear. This is not secured. This is not over VPN. But even from the get-go, I wanted to keep the exposure as limited as possible to anybody doing things that they shouldn't. So I used unique 64-character random SIP passwords, used IP tables on the actual Asterisk box to only allow registration from known IP addresses that I expect. And that was about as far as it went for now, and I'll talk a little bit more about securing it further in just a minute. But the other request that they had was to make this whole thing plug and play. So essentially we would take an endpoint, we would configure it fully, throw it in the mail, they would grab it, they would plug it in, and it would just work. And that all works well, especially if you know the other folks, where they're coming from on the internet. If you do have an update or you want to change something, I then allow TFTP transfer of config files across the internet to specific IPs to actually allow for updates, firmware updates, things like that. We found out that stickers help because people don't always tend to read the manual that they sign off on and say that they've read. So the resulting endpoint that we put out is just a standard Astra 53i. It has a few buttons on it. The simple button operation, we have two different page groups. One will page every endpoint in the cluster. The other will just page specific endpoints as they've defined. We try to put a quick reference sticker on there to let people know how to use this thing because, again, not everybody reads. And then we put notices on the phone itself that all the calls are going to be recorded. We tried to keep it simple. And this is a nice little snapshot of the sticker, if you can read that. So it's a simple three-step operation. You pick up the phone, you push a button, and you start talking. And if you need to talk from the other end, you hit the mute button to actually get on the call. The manual explained this in detail, but we found out that it doesn't always work that way. People don't always read what they say they're going to read. So more on that a little bit later. We had to also make the system a little more redundant, so I deployed a second Asterisk box with a separate ISP, redeployed all the configs with a backup server on the buttons, and it's never been used, which is good because our primary just stays up, does its job, and never has a problem, which is good for me and a testament to Asterisk as well. Every project, of course, comes with its set of challenges. And some of the ones that we had were having to work with extreme ranges of technical experts. We really had to end up securing the endpoints further because obviously just transmitting SIP over the internet is not secure. Pebcat, which I will discuss in a minute. Network latency and other network-related issues were also some big challenges we ended up facing. Technical extremes, we have some end users that were barely literate. It made for very difficult conversations about trying to troubleshoot an operation where the problem ends up. We also found out that most folks have not read the manual. And a lot of the system administrators that we talk to don't even understand the networks that they're running. So on the other hand, I had a bunch of highly skilled engineers that wanted to do things like QoS, endpoint encryption. So I'm dealing with all kinds of different extremes here. And a lot of times, I actually had to go in and explain to someone that they had network latency on their own network and where it was. And they didn't even know they had a problem with their network until I was pointing it out with the phones. So when we look back at trying to secure the endpoints a little more, for those of you who attended earlier talk on secure RTP here, that's something that I'm really looking forward to. But as I said, our initial rollout wasn't very secure. We began using the GNOME 370s that have OpenVPN clients built into them. So we built up this OpenVPN tunnel. We encrypted everything. It was going great. It solved a bunch of NAT problems, but it created a new problem for me in that my redundant server setup would no longer work because now my phone was having a direct tunnel to one place. I couldn't set up multiple tunnels, so I created myself another problem. And the other problem that I really wasn't expecting is the fact that the phone's looking much more complicated than the original Asters we deployed. It really threw us for a loop, and people didn't care for the look of that complexity of that phone. They didn't want it. They wanted the old thing. So that kind of shot that down. So now I'm investigating using secure RTP and Asterisk 1.8 as the next best option that we have. Since we don't have any control over the networks, we're not really going to go out and deploy VPN endpoints. Cisco 5505s at every location. That just adds too much to the overhead and the cost. And we don't always have a IP address on the other side that we can claim as our own. We also ended up with this nice little acronym, Pebcat. The problem exists between the chair and the phone. Inevitably, every month, somebody will not hang up the phone after they've initiated a page. So we record hours of conversations, sometimes just dead space, but some are not so flattering. We've had people talking poorly about their superiors, other people. And this is distributed to a very wide audience, and they're all just happily listening along. Nobody bothering to tell them that they're still on the line or being recorded. So now I'm looking for maybe putting a default timeout on the pages. But for anybody that knows what that is, that's a round to it, and I haven't gotten one yet. So network latency is, of course, the killer of VoIP. And troubleshooting that latency on other people's networks is not a fun thing to go through. When some of these networks, I would have multiple endpoints deployed, and I can see the latency on each of the different endpoints in that deployment. And I would see that, I don't know, 2 or 3 of their phones were quite acceptable. Wherein 2 other ones, or 1 other one, was very unacceptable. And it was causing call quality problems, people complaining, they couldn't hear, they couldn't talk. And in further investigation into what was going on, I started talking to these guys and saying, hey, look, there's a real problem with this particular thing. They started looking into it, and they found out that the phone was daisy-chained behind a PC, and the PC was infected with malware. And it was just spewing stuff all over the internet, using up as much bandwidth as possible, and of course killing the call quality too. So not having control over those endpoints is interesting, but it's always fun when you're opening somebody else's eyes, a problem they didn't even realize about. We did have some issues with double NAT translation. We got some folks that would put us behind more than one NAT translation. We ended up using Stun to try and get around that, and it works pretty effectively. And doing quality of service over the internet is almost always a futile endeavor. Quality of service works great if you're doing it inside your own network, but once you put that out on the wire, then most of your providers are just going to drop that the tag on the packet and forward it on as they see fit. And some of our locations are considering implementing an MPLS setup to dedicate the bandwidth for this application as it's grown in popularity and proven itself over time, just because they don't want to share the internet traffic with us and dedicate the amount of bandwidth that they need to the project. And we do have some MPLS setups working very well between our offices, but nothing for this project specifically. Everybody at every talk I'm going to always wants to know, well, how much did you save? How much did it cost? So I put together a little graph to show